press pause and answer the question.
Now let's look at a new data set. So due to uneven heating of different substances, there's a phenomenon termed the urban heat island or urban heat island effect. And on a sunny summer day, surfaces such as pavements and roofs can become hotter than vegetative surfaces. As a result, the air temperature around different surfaces can also vary. These effects can be felt both day and night, but time of day does affect those differences. Impermeable surfaces, which are impermeable means surfaces that don't absorb water, such as pavement and buildings, slowly release their heat at night. The graph below shows how different surfaces affect both day and night surrounding air temperatures. And then you have this graph, and you can see the day are here, and the night temperatures are here. And so the question is, between which two locations during a typical summer day, that's important day, so we're looking at these graphs, is the surrounding air temperature most different? So we're looking at this one. So the answer is this one, urban and pond. So what we're going to look at is we're going to look at this one. So let's make the other ones kind of fade away. And we're trying to find the biggest difference in a typical summer day. So the urban is way up here, and the pond, the urban is the highest, the pond's the lowest, so that's the biggest difference. That's the biggest difference. Now, what's happening? Well, there's a whole bunch of things. I mean, this is a park in Canada, in Montreal, and these are equal air temperature isobars, and this is degrees Celsius. So we have 14 degrees here in the middle of the park, and then it goes up to 14 and a half, and kind of at the perimeter of the park, it's 15. But as we get into the city, it goes to 15 and a half, and even higher to 15.7 or 16 or 16.5. So you can see pretty clearly as we move away from the park, the temperature is going to increase. And what's happening is if we have buildings blocking breezes that might flush out the air, if we have buildings that have what are called thermal mass, brick and concrete, do a good job of storing the heat during the day, they can hold on to that heat for the night. And so we have increased temperatures in urban cores relative to what we find like at the airport. They always tell you the temperature at the airport, but of course, nobody lives at the airport. It's the cities that we live in often, and these cities are increasingly holding their heat. Now, there are lots of ways to avoid this. We can plant more trees. We can use light-colored surfaces on roofs. We can plan our cities with parks, linear parks that allow the nighttime air to flush, and we can orient those linear parks to take advantage of seasonal summertime evening breezes to flush out the heat that's built up in the city, not just from the city absorbing the sun, but also all of the fossil fuels we're burning in the city from different equipment that generates heat.